Hello, today I will be completing a question from Chapter 19 where I will be solving for cell potential at non-standard conditions and through the Nernst equation by Widline Senatus. I am doing question 73. The question states, a voltaic cell employs the following redox reaction. Tin 2 plus aqueous plus manganese solid goes to tin solid plus manganese 2 plus aqueous. Calculate the cell potential at 25 degrees Celsius under each set of conditions. For A, we are at standard conditions. Standard conditions involves 25 degrees Celsius and 1 molar concentration of each of our substances. Because we are working in standard conditions, this means that we can use the equation of E cell at standard conditions equals cathode minus anode. To figure out which one of our substances is acting as the cathode and which one is acting as the anode, we will write down the half reactions for both substances. Tin 2 plus aqueous is going to tin solid. In this reaction, tin is gaining 2 electrons and therefore being reduced, so it is acting as our cathode. Manganese solid is going to manganese 2 plus aqueous and it is losing 2 electrons and therefore it is being oxidized, so this one is acting as our anode. Next, we would go into the back of our textbook and find a table so that we can find the standard reduction potentials of each of these 2 half reactions. In the table, we would find that tin 2 plus being reduced into tin solid would have a standard reduction potential of negative 0.14 volts. We would also find that manganese solid being oxidized into manganese 2 plus would have a voltage of negative 1.18. Next, we would plug in these values that we just found into our equation to calculate for E cell at standard conditions. We would be doing negative 0.14 volts minus negative 1.18 volts. And when you subtract by a negative number, you are essentially adding that value. And so you get a positive 1.04 volts for E cell at standard conditions. For B, we now have new concentrations of our substances, and we are still acting at 25 degrees Celsius, as was stated previously in our question. Because we now have new concentrations that are not 1 molar of each substance, we would have to use the Nernst equation, which is E cell equals E cell at the standard minus 0.0592 over N times log of concentration of products over concentration of reactants. We are using this equation rather than another equation, which would be E cell equals E cell at standard conditions minus RT over NF times log of concentration of products over reactants, because we are still working at the 25 degrees Celsius, and therefore that is taken into account with this equation. I have not written the other equation on paper because I do not want to confuse about which equation that we are actually using, but with this one, we are already taking into account the temperature that we are using. We already calculated E cell at standard potential in part A of this question, so we would be plugging it into this equation. And we would also be plugging in the concentrations of our tin 2 plus and also of our manganese 2 plus. To figure out which one of our substances is acting as the product and which one is acting as the reactant, we would go into our full reaction, and we can see that tin solid is on the product side, And since this is the solid, this one is acting as our product. Since manganese solid is on the reactant side, it is acting as our reactant. We then now plug in those specific concentrations into their proper places, and we will calculate a E cell of 1.11 voltage. For C, the concentrations of both substances have now flipped. So tin 2+ now has a molar concentration of 2.00 molar, and manganese 2+ now has a concentration of 0.0100 molar. We will be using the same Nernst equation because we are still at that 25 degrees Celsius mark. And therefore, we plug in our E cell at the standard that we already calculated in part 1, and we also plug in the concentration of products over the concentration of reactants, but now they are flipped from part B because the concentration got flipped, but the tin is still acting as our product in this case, and the manganese is still acting as our reactant. We would then calculate an E cell of 0.97 voltage. Overall, this question was asking us to calculate for cell potentials at standard conditions and also at non-standard conditions because it gave us different molar concentrations that were other than 1 molar concentration for each of our substances. We would do this first. For finding at standard conditions, we're using E cell at the standard, which is cathode minus anode. When we are at non-standard conditions, we would use the Nernst equation, which is E cell equals E cell at the standard minus 0.0592 over N times log of concentration of products over concentration of reactants. If the temperature was different in this case and we weren't using the 25 degrees Celsius, that means we would use the other equation, which would be E cell equals E cell at the standard minus RT over NF times log of concentration of products over concentration of reactants. But in this case, the question for all three was that it included we would be working at 25 degrees Celsius. And that is all.